Sometimes we need to catch multiple types of exceptions. For example, after reading a file, let's call reader.read. This reads one character and returns its numeric value. So let's store it in a variable called value. Now here we have another compilation error because we haven't handled the IO exception. So this read method may throw an IO exception if it cannot read data from this file. To solve this problem, we need to type another catch clause here. So catch, like here we want to catch an IO exception. We give it a name. And in this block, we can print a message like could not read data. The exception is gone. Now we have multiple catch blocks, and each catch block targets a specific type of exception. So only one of these will be executed. In this case, we try to open a file that doesn't exist. So this line will throw a file not found exception, and this catch block will catch that exception. Now, the code inside this catch block will get executed, and after that, the control will move over here. So this second catch block will get ignored, okay? So we have multiple catch blocks, and each catch block targets a specific type of exception. Now, does the order of these catch blocks matter? Sometimes it does. So if I move this catch block over here, you see a compilation error. The Java compiler is saying that we have already caught the find not found exception. What does this mean? Well, let's look at the documentation for the find not found exception class. So we type Java file not found exception. Here it is. Okay, so this class extends the IO exception class. And that means if we have a catch clause for an IO exception, we don't need this find not found exception. This is the polymorphism principle of object-oriented programming. We talked about this in the second part of this course. Let me show you. If I have a variable of type IO exception, let's call it X, I can set this variable to a new instance of IO exception or any classes that extend the IO exception class. So we can set this to a new file not found exception. This is polymorphism. An object may take different forms. So if you have a catch clause to catch an IO exception, this catch clause can catch an IO exception or any of its derivatives, any classes that extend the IO exception class, okay? Now, sometimes we want to treat these exceptions the same way. For example, here we can display a generic error message, but other times we want to handle them differently. If that is the case, then we need to bring back this catch clause and put it before the first catch clause. So now if we get a file not found exception, we can print a message like file does not exist. So we are giving the user a more specific error message, okay? Now, as another example, let's create a new simple date format object and call the parse method. Now here we have another compilation error because this parse method may throw an exception of type parse exception. Now we can put the caret over here, press Alt and Enter, and have IntelliJ add a catch clause for us. There you go. So it's right here. Now we have 3 catch clauses. Let's say we want to treat all of these the same way. So first we can get rid of the file not found exception. Now we have 2 catch clauses. We can combine this using a vertical bar. So right after IO exception, we type a vertical bar, then we type parse exception. And with this, we don't need the second catch clause. So this block can catch exceptions of type IO exception or parse exception. So these are different ways to catch multiple exceptions. The approach you take really depends on your application and its requirements. Next, we're going to talk about the finally block.